Welcome to the solutions to the cones and spheres question paper. So we're going to start off with this question here, work out the volume of this cone. Very important to make sure we're working out the right thing, not surface area. So we're going to need the cone formula. As it says here, the formula for these shapes are given at the front of the exam paper, although that's going to stop in a year or so's time, so it's worth just checking that your exam does get the formula at the front. So the formula you need, the volume of a cone, is 1/3 pi r squared h. And all you've got to do is shove the numbers in. So here we go. So we've got the 1/3, and then we multiply it by the pi. Now r in this case is the 5, so that's 5 squared times h, which is 12. And it's always a good idea just to challenge yourself, see how far you can get without a calculator. Obviously you could calculator this, but worth having a pop to see how far you can get. So we've got 1/3 and the pi. We can't do a lot with them just yet. Let's just simplify this. 5 squared is 25, and then the 12. Now you can't find a third of 25 easily, but you can find a third of 12. A third of 12 is 4, so you've got 4 times pi times 25. And you can do multiplications in any order. That's why I was quite at liberty to take a third of 12. 4 times 25 is 100, so you've got 100 pi. Now, if you put that into your calculator and hit the SD button, if you're using a Casio, you'll get the number 314.159 and some more. Now always check what the question wants. It wants 2 decimal places, so that's what we're going to give it. So there's our number, and then there's 1 decimal place, 2 decimal places. We're going to cut the number off here, so that 9 is going to make our answer 314.16. And there we are, 3 marks. Okay, question number 2. So another pyramid, this time it's a square-based pyramid. So the volume of a square-based pyramid is a general version of the formula we've just used. So it's a third of the base area times the height. And it's worth just going back and having a look at the previous formula just to compare it, because if you look at it, you'll notice that we've got the third, they've both got a third, and they've both got height, there's the h, and this bit in the middle, well, pi r squared, that's the area of a circle, which is the base of the cone, and the base area here, well, that's going to be a square for this one, but it works with any shape. So this is quite powerful. This is the one to learn down here, really. Anyway, let's carry on. So we've got our third. Now our base area here is a square, always check. So it's 6 times 6, so it's 6 squared, and the height is 10. So that's 1/3 of 36, because 6 is 36 times 10. A third of 36 is 12, and 12 times 10 is 120. Now we should always give units, so let's just make sure we've got that. So it's cubic centimeters. Let's just go back and check we did that before. We didn't, so again I'm pretty certain that's centimeters, so that should be cubic centimeters. It's the sort of thing you go back and check for at the end, so don't worry about not getting it first time. It says 3 significant figures. Well, we already have 3 significant figures. 1, 2, 3. There we go. Okay, last question on this side. A spherical ball. So we're dealing with a sphere here. Now, first of all, we're given the diameter. So let's just write down what the radius is. So the radius is 3.5 centimeters. We usually use the radius in the formula. So the volume is what we're after here. I'll work out the volume of the ball, and the volume of a sphere is 4/3 pi r cubed. Again, that's given at the front of the exam paper, but worth learning. So we just pop our numbers into it. So it's 4/3 times pi times 3.5 cubed. And if you shovel that into your calculator, you will get the number 51.31 and some stuff. So it says write your answer correct to the nearest whole number. So that's going to be 51, and again this is cubic centimeters. Okay, the challenge question now. So we've got a cone and it's been chopped up a bit here. So first of all, let's see what we've got. So the diameter of the base is 16, okay, that's on the diagram, and the slant height is 10, that's on the diagram, okay. Notice it's the slant height, not the height, okay. Calculate the volume of the cone and give your answer as a multiple of pi. Okay, now, first of all, volume of a cone. So we know that the volume is 1/3 pi r squared h. Now, the r is easy because we can see that r is 8 because it's halfway across, but the height, the h, is the problem because we've got the slant height, and what we want is the perpendicular height. And how do we get that? Well, we use Pythagoras. If you imagine that you could see that cone from the side, it would look like an isosceles triangle. And if we draw a line down the middle, you can see we get a right angled triangle. We know that that side is 10, and if that's 16, then that side is 8. So we can use Pythagoras. This side, which we're going to call h, is the square root of 10 squared minus 8 squared. I'm subtracting because I'm after a shorter side, because the 10 is the long side. So that is the square root of 100 minus 64, which is the square root of 36, which you may have spotted already. So the height is 6 centimeters, which means we can now finish off the first part of the question. So it's 1/3 pi, or radius is 8, so pi times 8 squared, and the height is 6. Now, the third and the 6 will cancel quite nicely. So we've got 1/3 of 6, which is 2. So we've got 2 times pi times 64, because that's 8 squared. 2 times 64 is 128, and 128 times pi. And now that is actually our answer, believe it or not, because that's the answer as a multiple of pi. This is normally something you see on a non-calculator paper or towards the end of the higher tier paper. Don't get worried about the multiple of pi thing, it just means don't use a calculator. And as before, this is cubic centimeters. Now, the second part of the question. The top 4 centimeters of the cone are sliced off parallel to the base. Work out the volume of the remaining solid. Now, this remaining solid has got an interesting name. If you want to look this up, if you chop off the top, you're left with this bit here. It looks a bit like an old school lampshade. It's called a frustum, and it's quite a useful little shape actually. Now, the problem with this is, well, the basic idea is very simple. We know the volume of the big cone. If we could work out the volume of the small cone, we could subtract it and leave the frustum. So what do we need to work out the volume of the small cone? Well, we know the height. What we don't know is the radius. So that's the first thing we've got to work out. So we're going to work out the radius of the small cone. Now, if the big cone looks like this, half of the big cone I should say, remember it was 6 high, we just worked that out. The radius of it is 8 and the slant height is 10. Then the little top cone, well, we know it's 4 and we want to know the radius. Now, because the little top cone has got the same angle as the big cone, because it was chopped off the big cone, and because these two angles are the same, because if they weren't, it wouldn't be a cone, it would be a kind of weird witch's hat like this. These two triangles are similar, which means that we can use these two pairs of numbers here to figure out a scale factor which we can use on this one. And it's a pretty straightforward one. Well, going from 6 to 4, there's two ways to look at this. You can either think of it as dividing it by 3 and then multiplying it by 2, or you can think of it as dividing it by 1.5. So it doesn't really matter which way around you do it. What you end up with is a value of 16/3. Not very pleasant. And you can see, just to sort of highlight this, if you divide 6 by 3 you'll get 2, and then 2 times 2 is 4. 8 divided by 3 is 8/3, and if you double it, times it by 2, you get 16/3. Anyway, we now know what our radius is. So this is our radius. So the small cone volume is 1/3 times pi times 16/3 squared times h, and the small cone is 4 high. And if you work that out, that comes to 1024 over 27 pi, and that's basic fraction multiplication. That's been worked out by squaring the 3, because it's in the squared, which gets you 9, and 9 times 3 is 27. And on the top it's 16 squared, which is 256. Multiply that by 4 and you get 1024. So the remaining shape, the remaining solid, which is called a frustum, that is the large cone minus the small cone. Now the large cone we worked out previously, it's 128 pi, and then we subtract the small cone. And if you do that, then you'll get 2432 over 27 pi. And again, it's cubic centimeters, and that's just done by fraction subtraction. Hope you found that useful. If you have any trouble, feel free to get in contact and maybe I can answer your questions.